This is the third class. The first time we came here to learn about Python, we just looked at the basic data structures that we need when we do data analysis, and in particular when we work with EMG data. During the second class, we began looking at these data structures in more detail. So we looked at the basic one, like lists, tuples, dictionaries, and so on. And we finished the last class talking about pandas data frames. So today we will continue from there. We will look at some more advanced topics of pandas data frames. Then we will move to NumPy arrays, which are a very important data structure when it comes to any numerical processing. So we'll see some practical things, practical implementations. And then we will also start reading some documentation. The documentation is the most important place where you can find all the information you need for your coding, but they are not of immediate understanding, especially if you're new to Python. And so we will walk a bit through some of them, some that may be interesting, at least in this first part of the classes. I remind you that we have a forum on GitHub where you can ask questions. You can see if somebody else asked the questions. It's like a space to interact with each other. And I also remind you to leave a star to our GitHub repository, which is always of great help. And as a last point of today's very short introduction, I want to tell you that last weekend we released a new version of openhdemg. We are still in a beta phase. That means that there is a lot that still needs to improve. But I think at this point we reached an almost stable, let's say, condition for the project because the functions in the library are robust. And what we needed to improve mainly was the graphical user interface. With the last release we solved some bugs and issues that affected the UI, which was sometimes crashing or preventing you to do some analysis. So now it is much more stable and reliable. Everything is working better, and it also has an important button, as you can see here, which allows you to customize the execution of the functions that the GUI is calling, so that you are, let's say, using the GUI, but you are one step closer to using the library because you can start adjusting some variables and parameters. So this is something you may find interesting, but today we are here to learn Python, so I hope you will learn also how to use the openhdemg library instead of the GUI, and I hope you will appreciate the flexibility of using custom functions instead of an application where the only thing that you can do is pressing buttons. So if there is no button, you will not be able to do something. On the other side, if you use a library, if a function is not doing exactly what you need, you can create your own function or modify the existing function. This is why we are learning Python. Okay, the presentation is finished, so we move immediately to the code. All right, let me close this one. So today we start with data frames. Last time we saw some important, but also I would say basic properties of the pandas data frames. And today we will look at the methods, which means the function that are part of each data frame that we create with pandas. So we start by creating a collection of data. We call it simply data. And we create it with a dictionary. A dictionary means a collection of keys and value pairs. And it's quite simple to understand why we use a dictionary to create pandas data frames. You can do this in many different ways, but the most immediate and simple one is to use dictionaries because we can create our key which in this case I want to name A, and R value pair, okay, which is gonna be a list, because it's once again the simplest way to create a collection of data. So in this case, my list is gonna be this. And what I'm doing here is creating a dictionary that contains a key A with 5 elements inside. And you can simply understand that when you build a table from this dictionary, the key will be the name of the column, while all the elements will be the elements contained in the row. So if I create a collection of more than one element, I just copy and paste it to don't spend too much time on that. You can see that now I have A, B, C, D, and E. So these are the columns that will be in my data frame, and each of these columns will have a different content. In this case, all the content is made of numbers. This is because today we want to look at some data manipulation for which we need to have data. We don't want to have strings or other things that cannot be part of mathematical operations. The creation of a data frame is quite simple. So we can create a variable that we simply call df, which stands for data frame. Obviously, this can have any other name as you wish. All right. First of all, we need to import the pandas library. So we can do it import pandas. Since we will call it many times, we want to import it with a short name, which is by convention named PD. So we import pandas as PD, and then we can access the panda by simply typing PD. And then with the dot, we can access a number of elements that it contains. In particular, we are looking for the class data frame. That is quite simple to understand, that is creating a data frame, okay? If you hover the mouse here, you can see this is a class that is creating a potentially heterogeneous tabular data. So as we said last time, every column of a pandas data frame can have a different length. If there are no elements inside, this will be empty rows of the data frame, which gives you some flexibility in what you can put in a data frame. But if you want to perform numerical processing, it's always better to have a uniform shape of your container. So that means a uniform number of rows for all the columns. But that said, the only thing we need to do to create a data frame from the dictionary data is to pass this information inside data. We can now print the data frame and see what happens. Okay, so as you can see here, we created a simple table. Let me zoom a bit so you can read better. We created a simple table with columns A, B, C, D, E, and 5 rows that are going from 0 to 4 because Python is in base 0. Now we may, want to see what there is inside. Now we only have 5 rows and 5 columns, so it's very simple. But let's say our data is bigger. We may want to plot the content of the data frame. And there is, of course, there are libraries that are specific for plotting, but there are also functions that have been already inserted in the data frame object that allow you to very simply visualize its content. To do so, we need to import anyway the basic Python library that is used for plotting, which is called matplotlib. And of matplotlib, it's a very big library, so we only want to import pyplot, which is the subset of functions that are dedicated to plotting things. Once again, we can, since the name is very long, we can use the short name that by convention is PLT. So we need this to show the image because the image is created by pandas, but it's not displayed to the user without using matplotlib. So we have our data frame that is df. We can access the attributes of the data frame, simply the functions that this data frame object contains. And guess how the function for plotting informations can be named is simply plot. Okay, if you start typing, you can see that plot is appearing. In this case, it's called, it's a property, it's not a function. You can see it is colored in blue and it's written property. We don't need to specify anything. We could make a plot simply like this, but we can also pass some optional parameters. So in this case, I want to specify the title, which can be data frame content. And then I need to show the image. So to do this, I need to use plt.show. Okay, it might seem something unnecessary, especially if you are coming from MATLAB. From MATLAB, you create a figure and it is displayed in most of the cases. In Python, by default, the figure is never displayed until you ask with the command show to display the image. Just to don't make it too long, but just to do the parallelism with MATLAB. If you want to plot different things in the same figure, in MATLAB you need to use the hold on function. So you say keep the plot there, add other things, and then at the end display it with all the information. Here the behavior by default is to keep plotting stuff on the same figure until you don't create a new figure or you decide to display the results. So this is why we need to call the show function, just because it's the opposite as in MATLAB. So we can execute our function again, our script again. And as you can see here, we have a column A, that is this one, a column B that contains this other information, and so on. So as you can see here, in a simple line of code, we displayed the content of all the columns of the pandas data frame. We also have a legend that is quite convenient. We put a title, and this is because pandas is a library that is made for simplified interaction with complex data structures that can be contained obviously in a table. Apart from visualizing data, let me move the import of matplotlib at the beginning of the code, so we will have it available also later. Apart from plotting the data, we may want to look, for example, at the numbers that are contained inside. We can do this via a summary statistic. In this case, we can print data frame df that describe. Describe this time is a method, so that means it's a function inside the data frame object. It takes optional variables. So if you want, you can specify the behavior of the describe function, but for now we don't need it. So we can simply execute the script. And as you can see here, it returns a description, a mathematical description of the data of the table content. So for example, in column A, we have 5 elements, as well in column B and all the other columns. But it also tells us that the mean of column A is 2.8. Then it tells us the mean of all the other columns, as well as the standard deviation, the minimum, the maximum value, and the quartiles. This is convenient. This is why we created a table with all numerical objects, because otherwise the functions that we are using from now on will provide a bit different results. Although the tables can work with any type of content, can work with strings, for example. Okay, this is interesting. Another method or function that we can use is, for example, the function sum. If you can imagine, this is performing the sum of the elements. And as you can see here, is returning the sum of column A is 14, of column B is 40, and so on. You have seen before we describe, you have seen now with sum, that all the operations are performed on each column. This is because, as we introduced last time, pandas data frames, but I would say tables in general, are organized as row major objects. So that means that all the operations are supposed to be performed on, column major. That means that all the operations are supposed to be performed on rows. Obviously, you can force the behavior of the function to perform the operation over, I'm doing a mess. All the operations are supposed to be performed on columns. You can force the function to do the sum across rows. In this case, you need to specify the axis, which is 1, to specify rows. And as you can see here, the sum of the first row, all the elements in the first row, 55, in the second row is 58, and so on. But since the default behavior is to perform operation over columns, this should tell you that the library has been built for this specific purpose. You can do the opposite, but you will be penalized in terms of performance and also in terms of correct functioning of the functions, because some errors that the data frame is automatically catching, some kind of conversions and so on, may be better optimized if you are performing operations over columns. So by default, you should consider the data frame as something that is supposed to work over columns. If you start performing complex mathematical operations over rows, your code will obviously work, but it will become slower and slower and slower because the way that the data is accessed, that the memory is accessed, is not efficient when done over rows. Okay? Again, this is an useful information if you start building more complex code. If you build only simple code, this doesn't make any difference. So we can keep looking at other functionalities, like, for example, the min method, which is obviously computing the mean value. But we also have the median, which is computing the median value. So in the end, you are repeating what you already obtained from the describe method. So similarly, we can have the standard deviation. And interesting, we can also calculate the correlation of the elements across the different columns. This is why I told you before, we could put any length of data inside each column of the data frame, but then some functions will fail because, for example, you cannot correlate 4 elements with 5 elements. So this is why we always try to have the same number of elements across all the columns. If we do the correlation here, you can see that column A is correlating with itself, obviously, perfectly. Column B is correlating to degrees to column A, to column C, D, and so on. So we can do that. There are obviously endless methods available for the data frame. We will look at the end of the class at how this can be found, how this can be learned by looking at the documentation. For now, I will display you just some useful one. And I will also start now slowly to introduce other libraries. So for example, we may want to visualize, to plot the correlation, so not just look at the numbers. because visualizing things is always making much more simple to understand what is happening. So in this case, we will use the seaborn library. Seaborn is a library made for plotting. It is built on top of matplotlib. That means that everything that you can do with seaborn can also be done with matplotlib. And usually basic libraries are always much more flexible, fast, and customizable. But on the other side, seaborn is making it much easier to perform a plotting operation of some, let's say, more complex things, because this library is taking care of all the, let's say, the processing. All right, so to do so, we may want to create a figure, which is in particular a heat map. So with colors, we are saying how much correlations are. So we access a seaborn that has been imported with the short name SNS. We access with the dot notation heat map. That once again is a function that takes a lot of things, but we care about just some of them. In particular, we want to specify the data. The data is going to be a correlation. So this table here. Then we want to use annotate true, which will display the values of the correlation. Then, I mean, we can specify, this is needed, but we can specify the color map. So I saw that whole worm is looking nice. And then let me do it quicker just to don't mess with the visualization. We may want to specify the decimal places of the correlation because these otherwise are very, very long numbers. Okay, we could hypothetically show the figure like this. Once again, we need to show the figure with matplotlib show function. If we execute the code, you can see here we have a very nice color map. And now instead of just looking at the numbers, we can see that column A is correlating perfectly with itself. Column B is correlating, very good. Column C is correlating a bit less. But then, for example, we can see that column E is almost not correlating with column C, or at least it has a very much lower correlation level. I will share with you the code that contains all what we did today. In the code, you can find a bit more functions. For example, you will see how to set the title, how to set the labels on the X and Y axis. So it will start giving you some tools to play with the plots, make them look a bit nicer. And this may be important for your, let's say, publications or whatever you need the figures for. And probably in the future, we will also do a class that is specifically designed for plotting, because it's always interesting and appreciated. Okay, so we saw a lot of things about data frames. Of course, not everything. I can introduce other few things like the count. Count is returning the all known not a number cells in each column. So we can say everything is a number. So every column we have 5 elements that are numbers. Or also strings, but that simply are not empty or something that is not recognizable. We can also use the unique, but in this case, we can use this method to see how many unique elements there are in a specific column. So I want to do this on column A. And if we look at this, we have 1, we have 2, 2, 4, and 5. So in theory, this should be 4, right? And indeed, it is 1, 2, 4, and 5. These are the unique elements in the table. This is useful because maybe you are doing a collection where you only need a value. You do not want duplicate values. So this is a good way to investigate the content of the data frame. Okay, so data frames are interesting. Data frames are very powerful. You should know, for example, that data frames are the most used data structure in machine learning, because before providing the data to your machine learning algorithm, you need to clean the data. So you need to remove non-number values. You need to scale and normalize values. And this is usually very simple, especially the part of exploration of the columns content is very simple with data frames. Also, you have a label for every column, so it's simple to classify in different groups what you need. But when you go inside the machine learning functions or any other function that is doing complex mathematical operations, including those that we need in electromyography analysis, you may want to have data structures that are more specialized in mathematical processing. These data structures are NumPy arrays. In this case, we need to import the library that we need. So we import NumPy with the short name, once again, NP. It's not, once again, it's not always fundamental to use the short names, but all the documentation you will read, especially for the big libraries, is using the short name. So you might better get used to it. And also it becomes much easier to write the code on the way, because you need to write much less things. We created before a data frame from a dictionary because we needed a collection of keys that are the columns names and values. Arrays do not have, as you also see, for example, in MATLAB or any other programming language, they do not have a name for the rows and columns and nothing. So we may not want to use a dictionary. And instead, guess what we can use? As we saw last time, the easiest way to create a collection of data is a list. A list can be created with square brackets. So if I only want a one-dimensional array, I could simply type numbers. But in this case, I want to create a data frame that has both rows and a dictionary that can have that has both rows and columns. So I need to create a collection of collections. And once again, I will use lists. Let's say I want to do 1, 2, 3, 4, and 5. Now it's not really important. So I created my first list. Then for simplicity, once again, let me copy the rest of the code. Then I create the second one, the third one, the fourth one, and the fifth one. Here, it is extremely important that the number for rows is the same across all the columns, because arrays, this is valid in Python, in MATLAB, everywhere, do not work if you have a particular, if you have an abnormal, non-uniform structure. Okay? As we did before, to create the data frame, we need to use a specific function to create an array. This will be obviously accessed from NumPy with the dot notation, and very simply, this is called array. So as we can see here, array is a function. So NumPy is structured a bit differently from pandas. So in pandas, we use a lot of methods that are functions of the data frame object, while in NumPy, we mainly use NumPy functions. They differ in syntax. in the end, they are doing the same thing. The only difference is that not the only, but the main difference from the technical point of view is that using functions instead of methods allows you a bit more flexibility. So when you are building complex functions like you have in NumPy, but you don't have in pandas, you need this kind of flexibility because you have much more constraints regarding the coding rules that you need to follow when you create methods instead of functions. So I create my array, and once again, I simply need to specify what data I want to use. Then I can print my array. And as you can see here, my array is composed as it is printed. I mean, it's not really understandable, but it's a series of rows and columns containing the elements that I specified. The first class we introduced the type, if you remember, which is a class that is telling you what a variable contains. And I told you it is fundamental because sometimes you can recognize it by eyes just by printing the results. Other times it will be impossible to print the results to display them because they are too big. But other times they might be very confusing because if you look at this one, you may think that this is simply a list of lists. So a nested list, a collection of lists, because the representation of an array is done with square brackets as well as lists. But if we print the type, we will see that this is not a list, but this is an NumPy array. So when you work with MATLAB, I'm doing this parallelism because I know that most of you only work with MATLAB. You can see written on your variable explorer what every variable is. You can double click on it and see what there is inside. But this is absolutely not possible in Python. There are some tools that are trying to allow you to go inside the data, visualize it with your eyes, but they are not working very well. And they have a lot of limitations, but both in Python and in MATLAB. So once you get a bit more into coding, you will learn that the best way to explore the data that you have, the data structure that you have, is to use the specific functions like type, or for example, we may want to see the shape. Why not? Because now we know that there are 5 rows and 5 columns, but if the array is very big, it will never fit your terminal, so you will never be able to understand how many rows and columns there are. We can simply use shape, similar to pandas. This is a property. If print shape, you can see that we have, so you see, I remember it wrong. We have 6 rows and 5 columns. The first number is always the row, and the second is the column. If we, for some particular operations, we need to only know the number of rows, we can print shape in position 0. So we index only the first element of the shape. And as you can see here, this is 6. If we have a 3-dimensional array, 4-dimensional, 5-dimensional array, how many dimensions you want, instead of 2 elements, obviously here we will have 3, 4, 5, and so on. So you will be able to access the position 0, 1, 2, 3, 4, and so on. Once again, we may want to understand what is this shape. So we can use again the type. And this is a tuple, as we saw last time. Tuples are a collection for something that is supposed to be immutable. This is because you do not want to modify the shape of your array unless you are modifying the elements contained in the array. One final important, one final important property is, for example, the type of the numbers contained inside the array. We can use the function dtype, the property dtype, which stands for data type. So in this case, you can see that there is an integer. If we only change one number and we make it a float number, you can see that the entire array is now float. This is because the arrays must have the same number of rows in every column, but they also must have the same type of data in every rows and column. So the more we look at arrays, the more we see that there are a lot of constraints. If you go to data frames, for example, you can put strings, you can put integers, you can put float. So you have a flexibility that you do not have when you use arrays. But on the other side, this smaller range of possibilities, the reduced flexibility of the arrays, makes them much more robust and much faster when you need to perform any operation on them, because you do not need to spend time to understand what type of data they are. You do not need to spend time to convert the data to some more appropriate ones. And you do not need to perform a comparison. So, let's say you have thousands of rows and columns. You need to look at everything that there is inside. So this will definitely destroy the performance of your code. So once you want to be more efficient, you also need to sacrifice flexibility. This is always a rule in coding. It doesn't matter what language you're using. Then apart from looking at the content in general of the array, similarly to data frames, we may want to index the content of the array. So, for example, we may want to see only the first row. In pandas, we saw the lock and ilock method. In arrays, we obviously do not have this because we do not have any label associated to the content of the data frame. So the only way we have to access elements is by position. So we must know what is contained in what position. And the indexing now is quite similar to MATLAB. It's obviously similar also to pandas. Because the developers try to make a sort of agreement between the various languages to make it easier for people that are often switching between the two languages. So, okay, let me put it back to integers because it makes the visualization easier. So if we print the element 0, what we are doing is printing the row 0. Because as I told you before, we always think about rows and columns. So if I only specify one thing, the array is supposing that I want to look at the rows. And as you can see here, we have 1, 2, 3, 4, and 5, the first row. If we put, for example, a slice from 0 to 3, as you can see here, we print rows 0, 1, and 2. As we said last time, slices, ranges, count the starting value, but do not count the ending value. So this is 0, 1, and 2. Okay, I think we saw a lot of things. So we can now start with the first hands-on task for today. This is quite simple, but I will give you a few minutes to practice. So what you need to do is we already have array, so you can use it again. I want you to access the first column, similarly to what we did with pandas data frames last class. But I also want you to access the second to fourth included row of the third and fourth column. And I also want you to create a new object containing all the rows of the first two columns. So if you want to try doing so, and then we look at the solution. Okay, I think we can slowly start with the first task, which is quite fast to do. So I want to print all the first column, okay? So we go my array, indexing with square brackets. So what I want to do now is to print all the rows, and I need to specify this. This can be done with the colon, then comma. Let's go to the columns, and I want to print the first one. So this will be the position 0. Let's see what happens. And there we go, 1, 6, 11, 16, which is this one. And I want to access the second to fourth row. So the second is number 1. The fourth is going to be number 4. So this is 1, 2, 3, which is the same as second, third, and fourth. So my rows are 1 to 4. And then third and fourth column will be 2 to 4. Okay. As you can see here, we have a subset of the original array. Then I want to create a new object. So I want to create a new array containing all the rows. So once again, all the rows and the first two columns. So going from 0 to 2. All right, I need to print. And there we go. We have 1, 6, 11, 2, 7, 12 that correspond to the first two columns. Okay, perfect. Now let me take some text that we can discuss together. So until now we looked at some basic, I would say, as we did last time with pandas properties. Properties are not performing any operation. They just give you information about the content of your data structure. And now we will look at NumPy functions. So we already said that they are similar to pandas attributes, but they have been designed to be much more flexible, much more powerful, much more flexible. But this is telling you a lot about the different nature of the two libraries. And in particular, we can summarize all what we saw up to this point by saying that pandas has been designed for quick access to data structure information, for simple and quick editing of the data that it contains, while NumPy has been optimized for efficient numerical operations. This is a bit more detailed explanation, and you can go back to this description at any time because all of this will be included in the code that is already shared with you. Although I will share with you a newer version that contains a few more things that we are looking at today. Okay, now we can create a simpler array. So this time we do not want a two-dimensional data structure. Let's start working with a one-dimensional array. So I call this one again my array, which is a NumPy array that contains simply a list. So we can use 1, 3, 6, 10, 15, 21, and 28. Okay, so we put numbers. Okay, it doesn't matter which number we put at the moment. A simple function that I can use is sum. So I want to print the result of this np.sum, and I need to specify the array where I want to perform the sum. And as you can see here, the sum of all these numbers it is 84. I may want to do the difference. And as you can see here, I obtain an array which contains the difference between one element and the subsequent one. If we want to look at electromyography, for example, with this simple function, we already created a differential derivation of our signal. Now we are doing this in a vector, which doesn't make much sense. If we do this in a two-dimensional arrays and we calculate the difference across rows, for example, we will have a real differential signal. Just to explain you that these simple functions then have a real application. Once again, we can calculate the mean. We can calculate the standard deviation. So this is working. I mean, NumPy, it's enormous. In NumPy, there are an endless number of functions. It's impossible to describe all of them. And we will see later on how we can learn this from the documentation. Just give me like 20 minutes and we go there. But now there is something about NumPy that I want to discuss with you. And now we imported NumPy as NP. We imported the main NumPy module. But the point is that NumPy has a lot of smaller modules contained in it. Each of them is specifically optimized and specifically designed to serve different purposes. It contains everything you need for, let's say, basic, but it's much more than basic numerical processing. So, for example, there is a module specifically dedicated to random numbers. So you can create arrays that contain random numbers. You can specify a lot of type of random numbers, specific distributions. But then you can use this module whenever you need some random things. For example, Monte Carlo simulations. that are sometimes used also in electromyography. But if we want to go closer to EMG signal processing, you may want to add some random noise to your signal that maybe you simulate. And or you want to see how some algorithms are performing if there is a noise. And then we have another module that is specialized on linear algebra. So you can solve linear equations, eigenvalues, eigenvectors, and all these kind of things. We have another module specific for the fast Fourier transform. This contains different functions for the fast Fourier, and each of them is slightly different, which complicates a lot working with this library, but in Python, with Python in general. But the slightly different functions offer a lot of customizability on the other side and always allow you to select the best approach for your specific study. So for example, for your specific data type, for the dimension of your array, or simply for the kind of result you want to obtain. Then we have a module that is specific for masking. So inside an array, you want to access only specific elements by some conditional rules. And this is where you use masking. Then there is a function, a module that is dedicated to polynomial fitting. And these are just a few, okay, modules. So there are many more. These are the ones we usually use when we work with EMG data. And but I mean, this will take forever to study all of them. So the best thing you can do is to look at the specific module you need based on your problem. And then when you are there, you go reading the documentation, you learn what you can do, you learn what is the best way to do what you need to do. So we saw a few things that are also a lot of things regarding arrays. So now I want you to put these things together. This is the last practical part we will do today. But I want to create a synthetic EMG signal. This is, come on, far away from being similar to a real EMG signal, but in a few lines of code, I can show you what we can do, okay? So we can create an array that contains random elements. So if I want to create an array of random elements, I obviously need to use the random module of NumPy. This can be simply accessed by the main NumPy module with the dot notation, and I can put random. As you can see, this is green because it's not a function, it's another module. Being another module, it is not doing anything. So I need to access specific functions inside it. And the function that I need is rand. I read the documentation. And this is creating an array of random values in a given shape. Now, I want to create a very large array, okay? I want to create an array with 1 million rows. And 256 columns. And you may say, oh, wow, why do we need such a huge array? Well, for example, this is an array of a fatiguing contraction that is lasting 7 minutes with a sampling rate of about 2000 Hz, so very common in EMG studies, with 256 channels that are also typical in modern EMG grids, or at least are becoming more and more common. Okay, we have this random signal, but we know that EMG signals are characterized by a mean that is usually 0. Now, in a very stupid way, I can create a 0 mean signal by subtracting to my array its mean. I specify a random array. So I'm calculating the mean value of my random array, and I am subtracting it from my array. Now, let's suppose that this is a real EMG signal. I load it from a file, so I get my random array variable, and I have no idea what it contains. So if I am in MATLAB, I can open it, go in the variable explorer, and start scrolling the 1 million lines that I have, read the numbers, and trying to understand what is going on. Obviously, you will never understand what is going on in your signal this way. This is why you should get used to look at the data from the terminal, from the script, from the functions, and not by looking at them. Because something that is happening in every field is that we keep working with data sets that are bigger and bigger and bigger, and they will become impossible to inspect by eyes, okay? And let's suppose that you do not have a two-dimensional array, maybe you have a three-dimensional, four-dimensional array. It will be impossible to visualize the content of this array. It doesn't matter what software you're using, MATLAB, R, Python, nothing will ever allow you to effectively visualize a multidimensional array. So just to tell you what is going on with this array, we can see how much memory this one is taking. And now I execute my script, which will take a while to create the array, because this is an array of about 2 gigabytes. So it's quite large. And we may want to, this is an information that I put here. We don't need it today, but when you start working with big data sets, if you're working with EMG signal processing, you will notice that at some point your computer will run out of memory, out of RAM. This is because we are storing somewhere this array. This is not disappearing anywhere. This is remaining in your computer as long as the script is running. And this is why NumPy has a property, the array have a property that tells you how many bytes they are. So if in your code your array is getting too big, your computer will no longer be able to process it. So you will need to find alternative solutions or to buy a better computer. So once again, it is impossible to go through all the functions, all the properties, all the things that there are in NumPy, like in any other library. But when you start having memory issues, you can go to the documentation and try to understand how you can see how large is your array. But in these situations, we may want to use the shape, for example. So we may want to see how big this is. And well, there we go. This is 1 million rows and 256 columns. You may want to do summary statistics you may want to calculate the mean, standard deviation, and everything. So for example, the mean here should be 0 because we created a 0 mean signal. Okay, so this is not exactly 0, but more or less 0. So we succeeded in our scope, but we may also want to plot the content of the signal. Now, plotting a signal of 1 million rows is a bit excessive. Also, we will not visualize anything in the screen. So we may want to plot a portion of the array, and that's where we need indexing and slicing. We also need the function, the library matplotlib. So in this case, we can use plt.plot, which is doing a basic, very simple plot. We don't have fancy stuff. We don't have legends. We don't have names of rows and columns and nothing. But this is just a basic approach to plotting. And also in NumPy arrays, we do not have methods for plotting. So we need to use an external library directly. And so we may want to plot our random array that is taking from row 0 to row, I don't know, now we can do 1000, so a small portion, and only the first column, okay? Right, I need to display the results. Okay, so you see, this is a perfect EMG signal. We will not find any motor unit inside here, but in few seconds, we created an array of random elements that is as long as 7 minutes of fatiguing contraction with a modern grid. We remove the min to make it look more as a real EMG signal. We investigated what there is inside, and we also visualized a part of this. Now we came to the end of the tutorial. So today was a bit lighter and also a bit more funny, but we can still look at some things to chat a bit. So at the end of the script that I will provide you very soon, like tomorrow, there is a section dedicated to the additional material. So there are tutorials, further reading that you can follow if you are interested in looking at lists, at tuples, at dictionaries, at pandas data frames, and also at NumPy arrays, which I tell you is quite complicated compared to the others. But this is because NumPy itself is more complicated. But there is also a section specifying some links to the documentation. Now, the documentation can be accessed directly from the website of the package. If you do not have the link, it's very simple to get the documentation because you can type, for example, pandas on Google, and you will immediately have pandas Python, which is the official website of pandas. Inside the website of the documentation, you find a lot of things that you most of the times don't need. You may want to go to the getting started section, but if you, let's say, have some basic knowledge of the tool you're using and you only need to learn the functions, properly how to use the functions, you want to go to the documentation section, which is often called also API reference section. And indeed, if we click documentation, we have this panel and we have the specific section API reference. Once you get inside the API reference, especially for these enormous packages, you need to understand what you need, where you want to look. So for pandas, we are using DataFrames. So you can see here on the left, there is DataFrame. You click there and you get all the functions that are inside the DataFrame. Let's start from the one we used, pandas.dataframe, which is creating a data frame. And you can see we can specify what data to use. We can specify the index. We can specify the names of the columns. So because, for example, we can build a data frame from an NumPy array, which doesn't have any column. So we can specify how we want the columns to be named. And we can also specify if we want to force the data type of the data frame to a specific type. Okay, so then we have, for example, lock and ilock. Last time we struggled in understanding how they are working. Here we have the documentation for them. And if we scroll down to the end, we also have a very nice example section. So you can learn a lot of things by looking at this. Similarly, we can go and look for NumPy. Oh, let me see what order I was thinking to follow. Yeah, we can go to NumPy. Once again, the website is organized in a similar way to pandas, so we can go to documentation. We go to API reference, and here it's a bit of a mess, but we can go to array objects. which is telling you what an array is, and then it's telling you how to construct an array. And here you have all the documentation. This is the class that we used before in the array, which is creating an array object that is multidimensional, homogeneous, fixed size, and so on. And it is telling you the shape you want, the data type, and other things. We have, for example, indexing arrays. So you can see here there is all the theory, all the math about memory allocation, and these kind of things. But then you can find some functions if you look here. For example, we can get the shape, as we saw before, the number of dimensions, if it's a multidimensional array, the size of the array, and you need the size to index it, because if you index an element outside the size, you will get an error. And then you have, for example, how you can transport your array and so on. So there are so many things. It's quite difficult to navigate the documentation, although you could write transpose here. Let's see if it works, and you get NumPy transpose. So it is working. But you can also do that from Google. So you can say to Google, for example, NumPy transpose, and it's smart enough to bring you that to the page with the specific function. Now, other two libraries that we saw today are matplotlib. So matplotlib is a comprehensive library for creating static, animated, interactive plots in Python. Matplotlib makes easy things easy and hard things possible. Trust me, it's not true that easy things are easy. We will see now how to make things easier when it comes to plotting, because matplotlib is a very advanced library, but it's quite basic and therefore quite complicated, but it's the most powerful one that there is in Python. And there we go to user guide. We don't have the documentation section, but it's more or less the same, and it's explaining you how to create axes, subplots, so how to manage figures with more axes and so on. No? You have the quick start guide that is very helpful. So the nice thing about matplotlib is that there are a lot of examples. So even if it's difficult, if you follow this type of examples here, you will make good plots in a few moments. Then the things get more complicated at some point, but to begin is not that simple. It's not that difficult. And then last library that we will look today is seaborn. Seaborn is a statistical data visualization library. It is built on matplotlib. This means it can do everything that also matplotlib can do, but it can do less things. The only advantage, the real advantage of Seaborn is that it makes things much easier. So let's click here, for example. This is an example. A plot like this in Seaborn takes a few lines of code. In Matplotlib, it may take hundreds of lines of code, okay? Because Seaborn is doing the hard work for you. Here, we do not have the documentation. We have directly the API. So on the API, we can see, for example, we can create a simple line plot. There are a lot of very nice examples. Seaborn is really user-friendly. So this is usually the first library that you approach if you want to do a bit more complex plotting. For example, we have the histogram. We have the Dodge. This is very, no. Let me see if there is a search button. So like, for example, we can have the seaborn swarm plot that can be very useful for your publications, for your figures. that's how it looks. You know, it can be very fancy. And in matplotlib, once again, this will be very, very difficult. And okay, so I think we saw everything for today. I wanted to make this class a bit shorter. So next time we will talk about object-oriented programming, which is the most important part in Python coding, which means functions and classes. And after that, we will go into openhdmg itself, and we will go direct to EMG data analysis with the openhdmg library. So we will need to read the openhdmg documentation. We will do this together, and we will start with the answer.